This question asks you to consider the reaction where iodine gas and chlorine gas form iodine monochloride. At 25 degrees Celsius, the K sub P is 81.9. You start with a container which holds 0.1000 atmospheres of each of the three gases. The reaction then occurs. Please find the equilibrium partial pressures of each gas. So you start by writing out the correct balanced equation, which we have here. Then we write out the K sub P expression, and we know that it's equal to 81.9. Next, build the icebox and fill in what we know, which is that everything is at 0.1000 atmospheres. Now that we have concentrations of everything, we need to know, are we at equilibrium? And if not, does the current set of situations favor the forward or the reverse reaction? We calculate Q, which for this set of circumstances is equal to 1. 1 is less than 81.9, so K is greater than Q, so the forward reaction is favored. That means that the iodine is going to lose some amount to X. And since the stoichiometry between the iodine and the chlorine is 1:1, the chlorine loses X, but the stoichiometry between the chlorine and the iodine monochloride is 2:1. The iodine monochloride will go up by 2X. So at equilibrium, the amount of iodine will be 0.1000 minus X. The chlorine will be the same, and the iodine monochlorine will be 0.1000 plus 2X. And K sub P here is not big enough that we can say forget about X. But I did give you the hint that you would not need the quadratic equation. So plug our equilibrium values into the K sub P equation and begin to solve. So the square root on the left is equal to the square root of 81.9. When you take the square root, you get these values. Rearrange to get this equation. Rearrange again to get 11.05x equals 0.805. So x must equal 0.0728 atmospheres. So now we can say the partial pressure of the iodine is 0.1000 atmospheres minus 0.0728. And so that's 0.0272 atmospheres. Because they have a 1:1 stoichiometry, the partial pressure of the chlorine is the same as the partial pressure of the iodine. Plug the values in for the iodine monochloride, and you get 0.2456 atmospheres. And if you plug these back into the K sub P expression, you do come up with a value that is exceedingly close to 81.9.